Hi everyone, welcome to DBA 110 Lesson 1, where we'll dive into cybersecurity and database design and explore how to protect sensitive information. Think about how often you rely on databases, whether it's student records, medical records, or financial data. This lesson will show you just how important it is to keep data safe. Let's get started. Before we jump in, let's pause for a moment. How familiar are you with securing data and database design? Do you know what role cybersecurity plays in keeping our information safe? If you're not sure, don't worry. We'll walk through it together, step by step. Here's what you can expect from this lesson. First, we'll define cybersecurity in database systems and explain why it matters. Then we'll talk about the difference between PII, that's personally identifiable information, and other sensitive data in a database. We'll explore user roles and access control, and how database management systems like Microsoft Access help us design secure systems. Finally, we'll discuss how to classify sensitive data, identify security risk, and use role-based access control to decide who should have access to different parts of a database. Cybersecurity in database systems is all about protecting stored data from unauthorized access, misuse, and theft. It's not just a firewall, it's a combination of policies, procedures, tools, and technologies working together to secure sensitive information. Databases often hold critical data like social security numbers, medical records, and financial details. Without proper cybersecurity, this information is vulnerable to hackers, inside threats, and even accidental exposure. Let's break down why cybersecurity is essential. First, it protects privacy so that private details don't get misused or sold. Second, it builds trust. People need to know their information is safe. Third, it keeps data accurate so that it can't be changed without permission. It also helps organizations comply with laws like HIPAA and FERPA, which require data protection. Finally, strong cybersecurity prevents costly data breaches. Without it, information can be stolen, altered, or leaked. Let's look at a real-world example. Imagine a hospital database gets hacked, exposing thousands of patient records. Those records could be sold on the dark web or used for identity theft. Or think about a school database being hacked. Student grades and personal information leaked online. It's not just about embarrassment. It can lead to legal trouble and loss of trust. In fact, many data breaches are caused by simple mistakes made by employees, so even small actions can have big consequences. What exactly is PII? PII is any piece of information that can identify an individual, either directly or indirectly. The National Institute of Standards and Technology defines it as data like your name, social security number, date and place of birth, mother's maiden name, or even your fingerprint. It can also include information linked to you, like medical, educational, financial, or employment records. If you can be identified by it, it's PII and needs to be protected. Here are some common examples of PII. Full names, addresses, email addresses, and personal phone numbers. Login data like usernames and passwords. Credit card numbers, social security numbers, and passport numbers. Even biometric data, fingerprints, retina scans, voice signatures, and medical records. Imagine if that information fell into the wrong hands. That's why cybersecurity is so important. To protect sensitive data, Organizations use a variety of tools and techniques, such as user authentication, making sure only authorized people get access, role-based access control, or RBAC, which we'll dive into a little bit later. Data encryption, which scrambles data so it can't be read without a key. Audit trails, to keep track of who did what and when. And of course, backups, to ensure data can be recovered if something goes wrong. All of these layers work together to keep data safe. User authentication is the first line of defense in database security. It's like a locked door that only opens for the right person. By requiring a username and password, we make sure that only authorized users are able to get in. This helps prevent unauthorized access, keeps sensitive data safe, and makes users accountable for what they do. Think about it. If just anyone could log in, the database would be wide open to attacks. Here's how logging in works, step by step. Number 1, the user is prompted to enter a username and password. Number 2, the system checks the credentials against what's stored, often using secure encryption. Number 3, if they match, the user is granted access. If not, access is denied. Number 4, once logged in, the user can only see or edit what their role allows. It's all about making sure the right people have the right access and no one else. Let's talk passwords. A weak password, like password 123, is easy to guess, making it a hacker's dream. A strong password is longer, harder to guess, and uses a mix of characters. For example, my dog $eats too! Is a way stronger password than password 123. It's like locking your front door with a key instead of leaving it wide open. Here's what makes a strong password. At least 8 to 12 characters long. Includes uppercase and lowercase letters, numbers, and special characters. Doesn't use personal information like your name or birthday. Is unique and not reused for other accounts. Remember, a good password is easy for you to remember, but hard for others to guess. Not everyone needs access to everything. RBAC, role-based access control, gives permissions based on user roles, like student, teacher, or admin. Instead of setting permissions one by one, you can group them by role. This makes managing access easier and much more secure. Think of it like a VIP pass. Some people get backstage, others only get to watch the show. RBAC has some great benefits. Improved security. Users only access what they need. Easier management, especially in large organizations. Better accountability. You know who did what. It helps with compliance. But there are also challenges. Assigning roles correctly can be tricky. Managing changes and maintenance can get overwhelming. And sometimes users get frustrated when they can't access something they think they need. It is really about finding the right balance. Encryption is like turning your data into a secret code. When you encrypt data, it's scrambled into unreadable text that looks like random letters and numbers. Only someone with the right key can unscramble it. That means even if hackers steal the data, they can't actually read it. Think of like putting your information in a locked safe without the combination. It's useless to the thieves. Encryption is essential for protecting sensitive information like medical records or financial data, and it's often required by law. Microsoft Access lets you encrypt a database file with a password. Without the password, the database cannot be opened or read. But here's a heads up. If you forget the password, you will lose access. So always keep your passwords in a safe place. Microsoft Access requires only 3 steps to encrypt your database. Step 1, open the database in exclusive mode. Step 2, encrypt the database with a password. Step 3, close your database and reopen it to see those new settings. Go ahead and click on the link on the slide to watch a video demonstrating those 3 basic steps. An audit trail is like a diary that records everything that happens to the data. It tracks who viewed, added, changed, or deleted data and when. It helps find mistakes or unauthorized changes and proves you're following security policies. For example, if a grade was changed, the audit trail would show who did it and when. How does an audit trail work? Every time someone makes a change to a database, the system is going to log it. The information that it captures could include who made the change, what they did, like what they viewed, edited, or deleted, which data was affected, when did it happen, including the date and time, and sometimes where they were when they made the change. This allows us to prove compliance with laws and regulation. You're able to restore data by knowing exactly what changed and when. This information is usually saved in a special audit log table, either within your database or is saved as a separate file. That file can be reviewed and monitored. Administrators can review the audit trail. They can use it to look for suspicious activity or unauthorized changes. They can also use that log to investigate errors or data loss. What would happen if your computer crashed and you lost all of your data? A backup is a copy of your data saved somewhere safe. It protects against mistakes, computer crashes, hacking, and even natural disasters. Types include full backup, incremental backups, cloud backups, and local backups. It's like having a safety net for your data. Creating a backup in Microsoft Access requires only 3 very simple steps. Step 1, open your database. Step 2, back up your database. Step 3, save your backup file. Go ahead and click the link on the slide so that you can watch a visual demonstration of how to accomplish creating a backup in Microsoft Access. Best practices for backups. Schedule backups regularly, like daily or weekly. Keep multiple copies in different locations, like in the cloud or on a local USB drive. Test backups by restoring your files occasionally. Check in to make sure they still work. Keep backups safe and secure. Always store your backup in a different location than your original database. You want to make sure that you can recover your data if something were to happen. What was the outcome of this case? Well, they had to notify all the users of the loss and be very transparent about the incident. They faced embarrassment, loss of user trust, and hours of downtime. Some of the lessons learned here. Test your backups regularly. Don't just assume that they work. Keep multiple copies of a backup, not just in the cloud, but also. Let's take a look at a case study. GitLab data deletion. In 2017, GitLab lost over 300 gigabytes of production data when an engineer accidentally deleted it. When GitLab attempted to restore that lost data, they discovered that their backup systems had failed. They discovered one backup was 6 hours old, but it was incomplete. Other backups were simply corrupt. Their most recent backup was from a day earlier, and it did not have all of the data that it should have had. What was the lesson learned here? Test your backups regularly and store them in multiple locations. What was the outcome of this case? Well, they had to notify all the users of the loss and be very transparent about the incident. They faced embarrassment, loss of user trust, and hours of downtime. Some of the lessons learned here. Test your backups regularly. Don't just assume that they work. Keep multiple copies of a backup, not just in the cloud, but also on site. Document and practice recovery steps so that you can act quickly in the event of a crisis. Let's review another case study. Snowflake data breach. In 2024, Snowflake's cloud database was breached. Hackers used stolen credentials and weak authentication to access sensitive information. The breach happened due to inadequate data security measures. We discovered there was a lack of multi-factor authentication, use of stolen credentials, and insufficient monitoring. The data breach had widespread repercussions. Data exposure. Sensitive information on millions of individuals were compromised. Financial impact. Companies faced significant costs related to this incident. Reputational damage. Trust was lost. Regulatory scrutiny. This breach attracted the attention of regulatory bodies. Some of the lessons learned here. We must enforce multi-factor authentication. We must have regular security audits. We must train our employees, and we must have a robust monitoring system to prevent these type of data breaches. Now that we've made it to the end of this lesson, let's take a moment to reflect on how much we know now about securing data and database design. Security is everyone's responsibility, and it's essential to keep sensitive information safe. Thank you for learning with us, and let's keep our databases secure.